Today we talk about how to get to the moon. NASA just came back from moon. They claim the Artemis 1 project went around the moon and it came back. And Korea sent a satellite to the moon, successfully got into moon's orbit. Everybody has a different method to get to the moon. After China landed a rover to the moon, actually India and Israel tried to get on the moon. And they both failed to land, but they successfully got into the moon's orbit. So everybody used a different method. I explained to you why everybody used a different method. Say you have a Earth here. How far is the moon? It's about 400,000 kilometers. So to understand that the distance, say ISS going around the Earth is about 400 miles above the Earth. 400 miles. Actually, let me look it up. 400 kilometers, not 250 miles, so about 400 kilometers. How about geostationary satellite? You know those satellite for broadcasting, dish antenna and stuff. And that one go around the Earth synchronously. Say if you have a satellite over New York, it's over New York forever. That means this circling speed and Earth spinning speed are synchronized, okay? And that's only, let me look at about 40,000 kilometers from center of Earth, okay? And we're talking about much more. It's 400,000 kilometers. The light speed is about 300,000 kilometers per second. So light speed takes about 1.3 seconds to reach to the moon. And if the lights come back, it's going to take another 1.3 seconds. So by the time lights come back, moon's already not there. It's moved already. So one of the conspiracy theory about why Apollo was fake was that astronaut here in Houston was talking in the video like without no delay time. It should have a round trip delay of 2.6 or about 3 seconds. But a lot of videos shows no delay time. And a lot of video was edited by NASA, so you cannot see it, but if you find the original one, it's obviously something wrong. And that was one of the conspiracy theory. Okay, so how do you get there? In order to get there, you want to get up to this level of orbit. This is high orbit. And this is a low orbit. And you see the big rocket to send the 3 crew members to ISS. That's only 400 kilometers above. We're talking about 40,000 kilometers. Now, how much energy we need to get up to this, say, distance. ISS is R1 and geostationary orbit is R2, and ISS mass is M1, and this is M2. We are talking about R2 over R1, M2 over M1. Okay? So geostationary satellite is very tiny, like several kilograms. ISS is ton. So you're talking about 1,000 difference. This is about 1,000. And R2 and R1, you see the difference, 100. So the energy level, is this equation, right? Remember, in the physics, we're talking about 100,000 more energy you need to get up to here. 3 crew member, NASA asked Russia to send it to ISS often, use a big rocket. But get up to this level is so much energy you need. Now, the gravity equivalent point is around here. The moon's is lighter, Earth is heavier. So here, gravity is going to be equal. Until you reach that point, you have to keep pushing your spaceship. So R2 is even bigger. And of course, the weight for spaceship is much bigger than, this geostationary satellite, which is only several kilograms. So you need huge rocket. And besides that, in the space, there's no reference point. Navigation system is an issue. How do you know whether your spaceship is on the way to the moon? Okay, the Apollo said they look at star and make a triangle and determine the location and stuff. But that time, they didn't have even the calculator to calculate the triangles. So it's another questionable claim. Without knowing where you are, it's pretty much you are in dark in space. And there's no way this orbit, you leave this orbit, and this may be slightly off, this way or this way, and moon is moving at the several Mach speed. This is a moving target in dark for such a long distance. This is pretty difficult task. So how do they do that? Now, India and Israel use a very safe method. You have Earth, the launch, and target moon here. Okay? And they use propellant to make it ellipse orbit. And every time larger ellipse and finally come to the moon and get onto the moon orbit. Okay? So this takes about 1 month. But it's a very safe way to get on moon's orbit. So that's what India and Israel, two eyes, did it. They were successful. They failed to land it. As soon as it's land, Israel lost communication. India was landing all the way about certain height, lost the communication. So both of them failed to land it. But getting to the moon orbit, if you take time, 1 month, there is a very safe way to do it. This is one way. Okay? And next method is China and NASA. Directly going. You have Earth and Moon. So get on the orbit and directly shooting to the moon. Moon is here. So how long it's going to take? You have to calculate how much moon moves before you go, right? And it's a let's calculate average speed, right? 400,000 kilometer, right? And in order to get there in 2 days, divide by 2, right? What kind of Mach speed you have to go? Divide by 24 hour, 2 days, 24 hour, and 60 minutes, and 60. And Mach is 350 meter per second, right? So if you calculate this, it's going to be about 8, Mach 8, Mach 8. But it's the average speed. What happens is, on the way, you have to keep pushing. It's very fast speed. You keep pushing. And from certain point, the moon's gravity kicks in, then it start accelerating so fast. And you have to be careful. It's too fast. You can't get into the orbit. It's going to go all the way, overshoot. And that's what the NASA did. It's NASA's Artemis. The Artemis orbit was ellipsis. You have a moon, and the test flight coming, overshoot, and it takes a while to come back. Moon moved, right? But because of moon gravity, it's pulled up like that. And it's overshoot again, and usually that's shown as this kind of orbit. But when moon is moving, actually spaceship movement is like this, and moon moves again. Because this ellipsis is very long, it takes a while. So when you come back to the moon, it's moved like that. Then from here, NASA fired a rocket, so it start going off the moon orbit, right? So it's left like that. Okay, then it came back to the Earth. The Chinese one, what they did is, when it gets close within the moon's gravity effect, they start the accelerate speed gradually. So overshoot is very controlled, then get into the orbit like that. Okay, so this is a Chinese method. Korea just launched the moon satellite, and it's very impressive. What's happened is, this is Earth, and they shot like that toward the Lagrange point and make a turn, and moon is going around here, synchronized speed here. And that means this satellite and moon synchronize, so much easier and safer to get into the moon orbit, like that. This, nobody used this method. This Korean did a very creative new method. It went all the way to Lagrange point and came back and synchronized with moon orbit and get into the moon. And this is, of course, quicker than Indian method, but you need precise control on the flight and radar. Now, nowadays, radar can track the object up to moon, so they can control pretty well, like this one and like this one. The radar, 1960 Apollo time, there's no such a radar, so I don't know what's happening. Once it's gone, it's gone. No radar tracking. It's just where they are is up to them. They have to drive Apollo by themselves. So astronauts basically manually operate. That's what NASA claims. That's one of conspiracy theory. How can you drive spaceship in darkness of the space? There's no 7-Eleven or anything on the way, so you don't know where you are. Okay, so this is very impressive. This is Chinese method, very controlled, speed controlled. NASA's not sure you get into overshoot and go big ellipses orbit. Then what do? You slowly adjust. The slowly adjust is going to take maybe 1 week, but you can't have that much many days if you send a man to the moon, because the men will die. This whole trip should be within 1 week or so. The China's method is like 2 days. This method, if you adjust elliptic orbit, it's going to take 1 week. Korean method got into nice circle orbit immediately, but you have to make an extra trip to fly around like that. Okay, so now you know there are many different methods of going to the moon. It's very entertaining to see. Every scientist has a different method, different idea of how to get there. Now, coming back from moon to Earth is more difficult. The reason is moon here, and this is the gravity equivalent point. From here to Earth, the Earth's gravity pull spaceship all the way, and when it's come to the atmosphere, it's like over Mach 20. And what's happened if you enter into atmosphere at Mach 20? It burns like meteor. Most of the stuff coming to the Earth burn because of the speed up too much by gravity. And what do you mean if metal and rock burn? It's like, iron and silicon, those rock material has electrons around the atoms. So this electron is peeled off and become plasma, and all the atoms become positive charge, then they disintegrate. So they disintegrated to small unit. So these electrons and plus atoms recombine and release light energy. So what's happened is when metal or rock come into very high speed, like Mach 20, it's like hypersonic speed, the material become plasma and disintegrate. And they recombine, release the light and bright shine lights. Then it's become small pieces and drop on the ground. Now, Artemis 1, NASA did, they didn't talk about how they get back at all. They just show the stuff came back and dropped in the ocean. So it's totally silent about how they get back. I'd like to get some technical paper about how they get back. The China's method, China got the moon rock sample and it came back. So what China did is the speed is too fast. It let it bounce once. And during this bouncing, speed slow down, then get into the circle orbit. Then it came back. This bouncing, if it's too shallow, its bounce become all the way to elliptic circle. If too deep, then you get into atmosphere that's too fast. So this angle is very limited. The tolerance is you need really good control on the spaceship to get into atmosphere and bounce once. And during bouncing, the heat dissipate and speed slow down kind of method. This coming back to Earth is much more difficult than going to the moon, actually, technology-wise. But too bad the NASA didn't talk about this at all. They just show the Artemis 1 floating on the Earth's, the ocean, and they pick it up and say, how did they get that from moon? Okay, going to the moon is technically 30%. Coming back to Earth is 70% of whole 100% round-trip technology. So I really like to see if any nation can really come back and talk about how they came back. The only so far China method is to bounce it and slow down. Okay, NASA never talk about this. And Korea just got to the moon. They have no plan to come back. India and Israel know they can go to the moon if they take 1 month of safe way to get there. Okay, so this is all the technical aspect of going to the moon and coming back. I hope you enjoyed it.